a look at empirical formula, we'll look at empirical calculations, we'll take a look at molecular formula and then molecular calculations, we'll take a look at some exam style questions, and finally a summary. So the first type of formula we'll have a look at today is the empirical formula. The definition of our empirical formula is that it's the simplest whole number ratio of atoms of each element present in a compound. So let's have a look at an example of calculating the empirical formula so we can understand this better. 6.2 grams of phosphorus is combined with oxygen to form 14.2 grams of phosphorus oxide. We want to work out the empirical formula of the phosphorus oxide. So the first step involves using our equation that we know, that the number of moles is equal to the mass over the molar mass. So we can fill out the masses first. We know we have 6.2 grams of phosphorus. We know it's combined with oxygen to form 14.2 grams of phosphorus oxide. So 14.2 grams is our phosphorus oxide. We know 6.2 grams of that is the phosphorus. So the remaining 8 grams is our oxygen. We now need to work out the relative atomic masses, which we can do by having a look at a periodic table. If we have a look at our periodic table, I've highlighted the phosphorus and the oxygen here. You can see the relative atomic mass of our phosphorus is 31 and oxygen is 16. So we can go ahead and fill that in. 31 and 16. Now, using the equation that the number of moles is equal to the mass over the molar mass, as I showed above, we can work out that the number of moles that we have of phosphorus is 6.2 divided by 31 to give us 0.2 moles. And for our oxygen is 8 over 16 to give us 0.5 moles. The fourth step is to divide through by the smallest number. So you can see that 0.2 is smaller than 0.5. So if I do that right here, we have 0.2 divided by 0.2 to give us 1, and 0.5 divided by 0.2 to give us 2.5. Now the final step is to work out the whole number ratio. You can see we've got 1 phosphorus to 2.5 oxygens. For the whole number ratio, we can double this to get 2 phosphoruses to 5 oxygens, giving us an empirical formula of P2O5. So let's go ahead and have a look at the molecular formula. Well, the molecular formula is ever so slightly different from the empirical formula. This is the number and type of atoms of each element in a molecule. It's taking the empirical formula a step further, if you like. So let's look at some calculations we can do to further understand the molecular formula. A compound has an empirical formula of CH2, but a relative molecular mass of 224. Hey guys, to continue watching